I'm Hank Kuiper, Technical Sales and Service with the SEFA Group. Today we're going to be doing some laboratory trial batches, but instead of the larger 1 cubic foot size batches, we're going to be doing what we call mini-mixes. It's a new procedure for us, and we're very excited to try it out for characterizing different ashes. The basic concept for the mini-mix is we would take a standard mix design for concrete in pounds and replace it with grams. So instead of batching 450 pounds of cement, we'd batch 450 grams of cement. We take out the coarse aggregate, so we would just batch the cement, the fly ash, the water, and the sand without the coarse aggregate. That allows us to have a representative mix, but we do it in the small Hobart mixer here in the lab. There are several advantages to doing it in mini mix. The first one is we can very accurately weigh and measure our materials. The mixes are very small and they're very light, and they're easy for 2 people to do quickly. We have 16 mixes today. We'll get all those done in about 2 hours. If we did this in a standard laboratory mixer, 16 mixes would take about 5 people a day and a half, and we'd all be very sore lifting buckets. Our test plan today with the mini mixes is to characterize many different ashes. One of the benefits I mentioned is that we can change one variable very accurately. And today's variable is going to be different ashes, specifically ashes from different ponds. We can make a control mix with an ash that we know very well, which will be our star process ash, and then we can change different ashes from different ponds or from different locations within the same pond and see the properties both in fresh, hardened mortar and through calorimetry. Many of the procedures we use in standard laboratory trial batching we use here in the mini mix. We mix for 3 minutes, we rest for 3 minutes, and we mix for another 2 minutes. We also make cylinders. We make 2x4 compression cylinders instead of the 4x8 or 6x12 inch cylinders we typically do in a standard laboratory mix. We also measure the unit weight of the concrete. In this case it's mortar because there's no stone. We measure the mortar, and we use the mortar to calculate air content if it's applicable. There is no standard procedure through ASTM for doing the mini mix. There are some proposed procedures, so many different producers and laboratories have developed their own. So we're taking some of the best procedures from ASTM and working together to make them into our own mini mix procedure. In addition to measuring the hardened and fresh properties of the mortar made with the different pond ashes, we're also performing semi-adiabatic calorimetry on the samples. What that means is we're very accurately measuring the temperature rise in the first 24 hours of the sample. The chemical reaction gives off heat, and by measuring the heat and plotting that, we get a very accurate profile of the heat development and how that mix is going to perform long term. At the SEFA Group, we believe we're the industry leaders in reusing fly ash, not only freshly made fly ash from the power plant, but from recycling ash that's been disposed either in ponds or landfills. Today's mixing is very important for us to be able to characterize ash from ponds so that we can determine which fly ash and which ponds produce ash that are suitable for use in concrete. This greatly expands the amount of ash available in the industry, and by harvesting it from the pond has enormous environmental benefits for the surrounding community.